Very good day to all of you students. Today in this class we are going to see the deadlocks and the deadlock prevention, mainly Banker's algorithm. Deadlock is a situation in an operating system where two or more processes are permanently blocked because each process is waiting for a resource held by another process. For example, P1 holds the printer and waits for the scanner, while P2 holds the scanner and waits for the printer. Neither process can continue, resulting in a deadlock. This is a very simple example. So, why do deadlocks occur? Processors need different resources to perform their work. Examples include printers, scanners, memory, files, database locks, and I/O devices. Normally, a process requests a resource, uses it, and then releases it. Deadlock occurs when processes hold some of resources while waiting for other resources. The four main necessary conditions for the deadlock are that deadlock can occur only when all four of the following conditions exist simultaneously. Number one, mutual exclusion. The second one, hold and wait. Third one, no preemption. And the fourth one, a circular wait. Mutual exclusion, which means at least one resource must be non-shareable. Only one process can use that resource at a time. For example, a printer may be assigned to only one process at a time. The second one is the hold and wait. A process is holding one or more resources while waiting for additional resources. For example, P1 holds the printer and waits for the scanner. The third one is no preemption. A resource cannot be forcibly taken away from a process. The process must voluntarily release the resource after completing its work. The fourth one is a circular wait. A circular chain of processes exists in which each process is waiting for a resource held by the next process. For example, P1 waits for P2, P2 waits for P3, and P3 waits for P1. Here, the chain goes on circularly. So, here, all the four conditions must exist for a deadlock to occur. If even one condition is prevented, deadlock can be prevented. So, what are the methods for handling the deadlocks? We can either prevent deadlock prevention, deadlock avoidance, deadlock detection and recovery, and ignoring the problem in systems where deadlocks are considered. So, today we are going to see this in the detail in the coming slides. So, this is what the deadlock. We are here in this slide, it is explained of what is a deadlock. In this slide, it is explained about the deadlock, that is the deadlock standstill scenario where multiple processes are permanently blocked because each holds a resource while waiting for another resource held by a peer process. So why do deadlocks occur? Now only I told no deadlocks occur. Uh, it will be the resource. The process will be requesting. Actually, it has to use and it has to release, but that will not get released. I said the example printer scanner problem. No, printer will be holding the scanner and the scanner can complete only the scanner will again it will wait for the printer. Likewise, it will be. So this is what I said, four necessary conditions for the deadlock: mutual exclusion, hold and wait, no preemption, and circular wait. The critical rule. Here it says that the all four must coexist. Actually, all four conditions exist simultaneously for a deadlock to occur. Remove even one, the deadlock cannot happen. So you have to break the brief mutual exclusion, break mutual exclusion plus make resources shareable, break hold and wait, request all resources at once, break no preemption, allow forced resource release, and we have to break circular wait. We have to enforce resource ordering. So the methods for handling the deadlocks are, the first one is the content, the difference between the two handling methods: deadlock prevention, deadlock avoidance, deadlock detection and recovery, and the fourth one is ignoring the problem. Deadlock prevention, it broadly restricts how resources requests are designed so conditions can never occur. Deadlock avoidance dynamically tests individual requests at runtime. The OS allocates the resource immediately if it keeps the system in a safe state or forces the process to wait if it leads to an unsafe state. Then, so in order to prevent the deadlock from occurring, the goal is designed to resource allocation such that at least one of the four necessary conditions can never occur. That is either the mutual exclusion, hold and wait, no preemption, or circular wait. Deadlock avoidance. So deadlock avoidance is fundamentally different from prevention. Rather than restricting how resources are used, the OS dynamically examines each request at runtime before detecting whether to grant or not. OS determines if granting the request keeps the system in a safe state. Safe, the grant and request immediately. Unsafe, the process must wait. So the most famous deadlock avoidance algorithm is the banker's algorithm, which was developed by Dijkstra. So, what is banker's algorithm? The basic idea of the banker's algorithm is just like using a bank analogy. Just a bank manages cash flow and will not grant a loan unless it can safely manage its remaining cash against customer demands. The OS will only allocate resources if it can guarantee that all processes can eventually complete execution. So the basic idea of the banker's algorithm is it shows the dynamic loop executed by the operating system when the resource is requested. Process request. Temporarily allocate. It will temporarily allocate the resources. It will check for the safety and it will grant the request if it is safe, or it will postpone the request. The key role is the OS never allocates resources purely because they are free. It must be actually prevent the allocation leaves the system stable. So the basic idea of the banker's algorithm is process the request, temporarily allocate, check for safety, grant the request. If it is not possible, it has to postpone the request. So the banker's algorithm relies on four key data structures maintained by the operating system for each process and resource type: availability, maximum, allocation, need. Only if it is available, it will be allocated. If it is not available, it will not be allocated, which will avoid the deadlock to occur. So this is how we can avoid the deadlock. But once, see, in the operating system, once when the deadlock occurs, nothing can be done. Once if it has entered into the deadlock uh, criteria, we have to restart or reset the system only. No other go. But in order to, we can avoid it or we can prevent it. So for avoiding only banker's algorithm is used. I hope all would have understood. Thank you all.